Hello and welcome to another video. In today's video, we will be going over the grade 10 paper 1 for 14 November 2025 from the Nelson Mandela Metro. Let's have a look at question 1. Question 1 says, without using a calculator, determine between which two consecutive integers the value of square root of 126 lies. Show all your calculations. With a question like this, the first thing we need to do is to take the square root of 126 over there, right? And we know it's lying between two consecutive integers. Now, what we need to do, or what you need to know, is that which two square numbers before 126 and after 126 do you know exist? The square number before 126, I know it's 121, and the square number after 126 is 144. Of course, once we find those two, we know that we have to square root the one before, square root the one after. Those are the two square numbers after 126 and the square number before 126. And then that is equal to, this is being 11, and that is the square root of 144 is 12. Simple as that. Somewhat of a trick for you to see if you have this correct. We go to our calculator, we take the square root of 126, we press our equal sign, we press the SD button, and we have 11.22. So the two consecutive numbers has to be 11, our answer we have there, and the number after 11, which is 12. And this indicates to us that we have the correct answer. Let's have a look at 1.2. It says, write 1.34 recurring in the form a over b, where a and b are integers and b is not equal to 0. Show all your calculations. The first step for a question like this, we want to convert this decimal into a fraction. Now, we first have to create the first equation that says x is equal to 1.34 recurring over there. This simply means it's 1.34, 34, 34, 34 up to infinity, right? So that is our first equation there. The next thing we need to do, we need to create a different equation. But the condition of the different equation is that the second equation must have the same decimal. So we may multiply this x, or this equation here, equation number 1, we may multiply it by 10, 100, 1000, any of the multiples of 10 to create a second equation. But the condition of the second equation is that it has to have the same repeating decimals. Let's try to create a second equation by multiplying by 10. So we say multiply equation 1 by 10. We say 10 times equation 1. That will give us 10x because we've multiplied x by 10. Then when we multiply any decimal, we simply shift the decimal once to the right, depending on how many zeros. This only works for the multiples of 10. So if we multiplied x by 10, we multiply this decimal by 10. This then gives us 13.434343. There's a bit of a problem here. After the decimal is 434343 for our second equation. After this first equation, decimal is 34. So simply because those two numbers after the decimal are not the same, this and this is not equal in terms of our values after the decimal, right? So we know multiplying by 10 doesn't work. Let us try to then multiply 100 times equation 1. Then we have 100x equals to, and we know that when we multiply the x with 100, we multiply the decimal as well with 100. But because there's two zeros now, this decimal point moves twice. So now I have 134, right? It moved twice over here, just to indicate to you. 1, 2. So I have 134.343434, and it carries on. We have now successfully created two equations where the decimals are exactly equal. So now we have two equations over here, right? The first equation is 100x equals to 134.343434 recurring, and the first equation is x equals to 1.343434 recurring. The next step now, we take the second equation and we subtract it with the first equation. Okay, so now we have 100x minus x. Okay, so we take the second equation, we subtract the x value for the second equation by the first equation. Then we have equal. So we're going to take then the 134.343434. That's recurring. And we subtract it from 1.34 recurring. Okay. Now we have an equation and we can cancel out these decimals. So firstly, this now gives us 99x is equal to 134.34 recurring minus 1.34 recurring. Firstly, since the decimals are the same and we're subtracting, now the decimal falls away. So this answer now is 134 minus 1, which is 133. We have successfully achieved our aim of getting rid of the recurring decimals, which will help us in turn to write this in the form of a fraction. Now to solve for x, we divide by 99 and we have x equal to 133 over 99 over there, and we have successfully written 1.34 recurring as a fraction. Again, there's a way we can test this. We can have 133 divided by 99 and we press the SD button and we have 1.34343434 recurring. This indicates to us what we did is correct. So for both of these questions, it is testable whether your answers are correct or not. Let's have a look at question 2. Question 2 says factorize the following expressions fully. 2.1.1 minus 3p squared q squared minus 12pq3, sorry, 12pq to the power of 3. When I look at this, right, the first thing I see, or both of these terms, I can see common variables. So I would go in the direction of the type of factorizing would be common factor. Okay, now we have numbers. Before the numbers, we have a sign, we have a negative sign. When we have a negative sign, we also take that negative as common. Okay, then we have the number 3 and the number 12. Okay, between 3 and 12, the lowest common factor, right, between 3 and 12 is 3. Okay, in fact, we take the highest common factor between 3 and 12, which is 3. Then we look at the variables or the letters. So there's p squared and there's p over there. So the only common one is p that we can take. We have q squared and q to the power of 3. So the highest common factor we can take there is q to the power of 2. Now we open up our brackets. We took the entire minus 3 out of the brackets, so there's no letter for the first term. We took p out of p squared, so what is left is p. We took the entire q squared out of the bracket, so we are only left with p for the first term. We took out the negative, so this becomes a plus over there. We took 3 out of 12, so we are left with 4. We took the entire p out of the second term, so there's no p left. We took 2 q's out of the second term, and there were 3, so we are only left with 1 q, and we close our brackets. And that's the final answer. In the second question, I see 2 terms. I see a negative. The moment I see 2 terms in a negative, I veer towards difference of 2 squares. But for me to confirm that it is difference of 2 squares, then the 2 terms has to be squares. Is 81 a square number? Yes, it is. Is y squared a square variable? Yes, it is. Is 4 a square number? Yes. So we have 2 terms that we are subtracting that are square numbers. So we can call this the difference of squares. So we know with difference of squares we create 2 brackets over there. So for the first term, the square of 81 is 9. The square of y is simply y. Then we have a plus. The square of 4 is 2. So we have that first bracket. And we repeat ourselves in the second bracket, except now we change the signs. Okay? And that is the final answer over there. 2.2. Simplify each of the following expressions. Let's have a look at 2.2.1. We have 2k minus 3 in brackets squared minus 3 brackets 3 minus 4k. So we have this over here. The first thing we do is we duplicate those brackets. We have 2k minus 3, 2k minus 3 over there. Then if we look at the second term over here, we have minus 3 and we have a bracket. The moment we have a letter or variable, anything outside that, outside the bracket, we know that we simply take the variable or the letter number, we multiply it with every term inside the bracket. It's called the distributive property, if you didn't know. So minus 3 we multiply it with the first term, which is 3. That gives us negative 9. Minus 3 multiplied by minus. So 2 negative numbers, first of all, gives us a positive. 3 minus the 4 gives us 12. And the k comes along. Next we have a binomial and a binomial, which is 2 terms multiplied by 2 terms. So the first thing we do FOIL. So we multiply the first term inside with the first term of the second bracket and the second term of the second bracket. So we say 2k that multiplied by 2k and 2k multiplied by negative 3. So let's do that first. This now gives us 4k squared, and then 2k multiplied by minus 3 gives us minus 6k. We are not done because you also have to multiply the negative 3 to the first and second term of the second bracket. So we have minus 3 multiplied by 2k, which is minus 6k as well. And then minus 3 multiplied by minus 3 gives us positive 9. And remember, this forms part of our expression. Even though we didn't touch it, it falls with. So it remains minus 9 plus 12k. When we have all of these terms, we try to put all the like terms together. So we have 4k squared. There's nobody else that's a like term with 4k squared. Then we have minus 6k. This we can already simplify to give us minus 12k, not 0. Okay, and then we have plus 12k. I'm going to shift it over to the side, and we have plus 9 minus 9. Okay, so like I previously said, 4k doesn't have anybody else to subtract or add. Remember, we may not add or subtract unlike terms. However, minus 12k plus 12k are like terms. That gives us 0. Plus 9 minus 9, that gives us 0. So technically, we are left with 4k squared plus 0 minus 0. but we're not going to write plus or minus 0. So our final answer is simply 4k squared. Let's have a look at 2.2.2. We have a fraction. We have an exponent. We have three different numbers, okay, with an exponent. The first thing we need to try to do when it comes to a fraction and exponent with something like this, we need to try and get our bases the same. So this 15, let us try to convert it in such a way that it has one of the same bases as 5 or 9. Now, we know that 15 can be rewritten, and this is very important that when you rewrite these numbers that you use brackets. So 15 can be rewritten as 3 multiplied by 5, and in brackets there we have 2a minus 1. I chose this and I know I'm in a good direction because now this 5 and that 5 is the same base. That is still over. This 9 we can change to be 3 squared. That helps us now because we have now another base that is similar. So we have 3 squared, very important, brackets. And then we write our exponents, a minus 2, dot, which means multiplication, 5, 2a plus 1. Now, we try to simplify even further. These exponents need to go to their bases. So we have 3 to the power of 2a minus 1 dot 5. The dot is just a multiplication. 5 2a minus 1. Those exponents go to each of the bases. All over. Now I have 3. This 2 gets multiplied with each and every exponent on the outside there. We have 2a minus 4. Very important there. Dot 5 2a plus 1. Now what's very important over here, we have same base, same base, same base, same base. We have taken the correct root, shall we say. Now that we have the same bases, we know that the division sign means once we divide the same bases, we subtract the exponents. So now I have the base of 3, the exponent of 2a minus 1, and I subtract. Very important is that I use brackets. If I don't use brackets, I'm going to come across a sign error in the future. So it's brackets 2a minus 4 dot 5, the exponent 5 over there, and now I have 2a minus 1 minus brackets, very important, and I use 2a plus 1, close the brackets over there. So now I can focus a little bit more on the exponents. I have 3 2a minus 1, that negative gets multiplied inside each term in the brackets, goes like that. So it's minus 2a plus 4 dot 5. We have 2a minus 1, again, this negative sign gets multiplied to each term inside the bracket, minus 2a minus 1. We're still focusing on the exponents because there is more simplification that can be done because there are still like terms in the exponents. Okay, so we have 2a minus 2a. I'm just gonna, we don't have to group them because if you can do it with seeing it, it's much better. You're saving space as well. So I can see 2a minus 2a. That's going to give me 0. Okay, I can write 0 over there. You don't have to. Minus 1 plus 4 gives us plus 3. So in other words, 0 plus 3, that simply is 3 dot 5. 2a minus 2a, again that's 0. We're not going to write it. Minus 1 minus 1, that gives us minus 2. When we simplifying and when we're solving, we like to have our exponents as positive. There's a problem, the exponent is negative. When the exponent is negative, we can change it to a positive exponent so long as we switch it either from a numerator to a denominator or from a denominator to a numerator. Since it's a numerator, we're going to switch it to the denominator. That gives us 3 squared. Now it's at the bottom. 5. Now the squared, or the 2, is a positive exponent. And then finally, that's equal to 3 squared, which is 9 over 25. Now, we have an exponent over here that is negative. We do not want that. For us to convert an exponent to positive, we either switch it from the numerator to the denominator or from the denominator to the numerator. Since it's already a numerator, right, we can switch it to a denominator. We have 3 to the power of 3 over this now goes to the bottom. It becomes a denominator, 5 squared. 3 to the power of 3 is 27 and 5 squared is 25. That is our final answer over here, all the way from this. Right, let's have a look at 2.2.3. This is quite a lengthy one, as we can see, and it is probably some of your worst nightmares, which is fractions. Okay, when I look at this, I see what can I factorize, and we start with the denominators. Okay, so when I look at the denominators, I want to see if I can find some common denominators which can assist me to simplify this any further. So I look at x plus 3, I look at the first fraction, there's nothing much that I can do over there. The second fraction, for now, there's nothing that I can do. And over here, I spot a trinomial. Okay, so first things first, I can factorize this trinomial, right? So I have 2x plus 1 over x plus 3 minus 5 over 2 minus x minus, I'm still rewriting everything over here. And when I factorize this trinomial over here, so I'm just going to skip a little bit. I'm sure you can factorize this by now. So when we factorize this, just quickly, we have positive 3 and a negative 2. Yes, that's just my quick way of doing it. So we have x plus 3, x minus 2 after factorizing that trinomial over there. Then when I look at these denominators here, I see x plus 3. I see x plus 3. Okay, that means I'm going into a good direction. I see 2 minus x. I see x minus 2. There's a problem here, and there's a way to solve this problem. If only the 2 was a negative and the x was positive, like this one, then I would have 2 of the same brackets in the denominator. But can I change this to look similar to this? The answer is yes. What is key is to take out the negative over there. If you didn't know how to do that, you will probably struggle with this. So I take out the negative. I have a negative outside, and I put brackets. And I simply change the signs inside. So then that becomes a negative, that becomes a positive over there, right? And now I have this. Now, to make things easier, I can rewrite it as x minus 2 with a negative outside the bracket there. So I've rewritten this as this. This is a trick maybe you should have learned, or maybe you were looking out the window in that lesson, and then when you look back, you missed it already. It's one of those quick tricks. So now I have minus x, minus 2 over there. And then because I have two negatives outside the bracket in the same fraction, a negative and a negative, that gives me a positive. Okay, so that is how that just affected this entire fraction over there. Looking at this now, we now have an LCD. The LCD is in brackets x plus 3 brackets x minus 2. That is our LCD over there, our lowest common denominator. So remember, this is not an equation, so we cannot multiply. I know some of you mistakenly get rid of the entire denominator by multiplying this and cancelling it out. We cannot do that. This is an expression. Okay, so Let us write our big fraction over there, our LCD that we have picked from here, we found, goes to the bottom, x plus 3, x minus 2. What we do with this LCD, we take it, we multiply it with the first term. Okay, so we have x plus 3, x minus 2, we multiply it with the first term. We see that since that and that is the same, it will cancel, leaving us with x minus 2 brackets 2x plus 1. Okay, so what I've done, I've taken the LCD, I multiplied with the first term, the x plus 3 is cancelled, and I was left with 2x plus 1, and I'm left with x minus 2. And I take the positive sign over there. Again, I take my LCD, I multiply it with the second term. Now the denominator is x minus 2, meaning the x minus 2 is going to cancel. Then I'm left with x plus 3 brackets 5. The order is not important over there. Okay, then minus this fraction needs to go on. The LCD is x plus 3, x plus 3, x minus 2, x minus 2. For the third term, both of these brackets cancel out, so I'm only left with 10x plus 5. All right, so now I look at the numerator and I'm going to simplify because there's a lot of FOIL and multiplication and adding that needs to be done there. So first things first, I'm going to take this brackets there and do my FOIL. Over there, I'm going to move it faster. So that gives us there, we have 2x squared there, and then we have plus x. Very important to take your time here because this is where the mistake's coming. Then we have minus 2 multiplied by 2x. We have minus 4x, and then minus 2 multiplied by plus 1, which is minus 2. Maybe we're going to run out of space. Then we have, the order here doesn't matter, hopefully you are not confused, but x multiplied by 5, which gives us plus 5x, and then 3 multiplied by 5, which gives us plus 15. Then we have minus 10x plus 5. Sometimes you guys forget to bring this along, right? So that is all over, still staying with us, x plus 3 brackets x minus 2. Now what's important over here, sometimes we will make a critical error when we have this fraction over here, right? This negative applies to the entire numerator. So now when we cancel out the x plus 3 and the x minus 2 with the last term, this negative sign, very, very critical, one of the most critical errors when it comes to working with fractions, is that the negative sign applies to all the terms inside or on top of the fraction. So it's negative 10x, and this is not positive 5, this is negative 5. Now we try to simplify this numerator over here. We take the x, these two brackets, and we try to multiply them. The x multiplied by the 2x, that gives us 2x squared over there. And then the x multiplied by the 1, which gives us just plus x. Then we take the minus 2, we multiply it with every term inside the bracket. Minus 2 times 2x, it's minus 4x. And minus 2 times 1 is minus 2. Then we have plus. The order of this doesn't matter, but anyways, the x we multiplied with, since it's in brackets, we multiply with the 5. That gives us plus 5x. And we take the 3 multiplied with the 5. That gives us 15. Then we have minus 10 and minus 5 that we carry along. Now on the top, we have a bunch of terms we need to simplify. And we're going to try to simplify them now. As you can see, I've indicated the like terms with colors. Unfortunately, 2x squared does not have any friends. No like terms with 2x squared. We have plus x minus 4x plus 5x minus 10x. Okay? You should be able to do that without grouping them together by now, since you are in grade 10 doing pure maths. But if you need to, you can do it on the side, but I'm going to skip it. Plus x minus 4x gives us minus 3x. Plus 5x gives us 2x. Minus 10x gives us minus 8x over there. And then we have the numbers minus 2 plus 15 minus 5. So minus 2 plus 15, it's plus 13. Minus 5 gives us minus 8. That's still all over x plus 3, x minus 2. Do not forget to keep bringing the fraction along, the denominator along. When I look at that, we are still not finished. I ask myself, can I factorize further? Can I simplify further? I see at the top a trinomial, but before the trinomial, you see a common factor of 2. So I take the 2 out, I have x squared inside the middle, minus 4x minus 4 all over x plus 3, x minus 2. Now, can I factorize this trinomial? The answer is yes. I think I have taught this method in one of my previous videos. So then, factorize this trinomial however you may do it. I'm sure you can do it fine by now. I have excuse me. Yes, I've spotted an error. This is supposed to be plus 8, not negative 8. I know some of you rush to the comment section to fix me. Beautiful if you spotted it over there. So that's supposed to be a positive sign. You see? Sometimes when you see that, I saw that I couldn't factorize this trinomial, and I went to check, did I make an error in the previous calculations? You know, sometimes that gives you an indication when you can't factorize something further, or when you're stuck with something ugly like this, you can't simplify. Maybe there's an error upwards. Okay, everybody can make mistakes. So then we have minus 2 over there, and I can simply factorize that trinomial to have x minus 2 all over x plus 3 x minus 2. Now I can cancellation. Since all the signs are in brackets, now I can cancel. I cannot cancel in these moments over here. Okay, so now I can cancel this and there, and I'm left with 2 brackets x minus 2 over x plus 3. I can go even further to say 2x plus 4 over x plus 3 is my final answer. Let's have a look at question 3. So for question 3, we can see there is a minus section outside the bracket and there's a 2x plus 7. Now your first instinct might be to multiply this negative x inside the brackets. However, if you are familiar with the zero product rule, for example, the zero product rule, if we have two terms or two variables multiplying, the zero product rule states that we can let the first variable equal to 0 and then the second variable equal to 0. So that's all. So we have two possible solutions over there. We can do something similar. Minus x first. So minus x equals to 0 and that simply equals to 0. So we can say, or 2x plus 7 equals to 0. So we have two possible solutions when we apply the zero product rule. So then we have taking the 7 over, it becomes minus 7. We then divide by 2 to find x. Therefore, our final answer is x equals to minus 7 over 2. Okay, so we have two possible solutions for this equation over here. Over here we have a trinomial. So we're going to solve this trinomial, or we're going to factorize this trinomial first. So this is the method that I use. I apply a x over there, and then these two terms give me the first 8x squared over there. I'm going to go with 4x and 2x over there. and then I need to choose factors of 9. So I can either choose 9 or 1 or minus 3 or positive 3, but that needs to give me the middle term. Some of you might be confused with this method that I'm using. You can apply your own method with this question. Okay, so what I would have over here, I would have minus 3 there and a positive 3 there. This gives me 12. This gives me 6. And my final answer will be 6x when I go across like this. But anyways, then I have 4x minus 3 brackets 2x plus 3 equals to 0. Now I factorize the trinomial. Whatever method you use, perfectly fine there. You might be a little bit lost with this method, as I'm not going to too much detail with it right now. So now I have two brackets, right? And according to the zero product rule, I can let this bracket equal to 0, or I can let this bracket equal to 0, meaning I would have two possible solutions. My first possible solution would be 4x minus 3 is equal to 0, or 2x plus 3 equals to 0, right? And I solve this first equation over here. I can skip some steps, take the 3 over, divide by 4. That would give me 3 over 4. Same over here. We should be good with this by now. It becomes minus 3 on the other side, and we divide by 2. And that's our two possible solutions over there. Let's have a look at 3.1.3. Here we have the variable in the exponent. So what we need to try to do is try to get all the bases the same when we're solving exponential equations. So we're going to change this 25 and rewrite it so that it has a base of 5. And we can rewrite that as 5 to the power of 2. When we do this, we have to do it in brackets. And then the other exponent is on the outside. Apologies there. Is on the outside. That's equal to 5 minus x minus 2 dot 5 to the power of 2. Once we get to this stage over here, we know that this exponent over here multiplies with each exponent on the outside to get rid of the bracket. Okay, that's our exponent law. So now we have 5, 4x plus 2 equals to 5 minus x minus 2 dot 5 to the power of 2. Here we can also apply one of the rules that we know. Since this dot means multiplication, the bases are the same, so we can simply add those exponents over here. So now I have 5 4x plus 2 equals to 5 minus x. There's no other variable with the x to add there, so I have minus x minus 2 plus 2. That gives us 0. Okay, just I'm going to write that on the side. The minus 2 plus 2 equals to 0. We've added these exponents, and that is why there's nothing over there. Now that we have the bases the same, we can now equate the exponents. So these exponents over here, we can create a new equation with only the exponents and state the following. 4x plus 2 is equal to minus x. Now we have a simple equation that we can solve. So we're going to take x over to the left hand side. We have 4x plus x equals to, and I'm going to take the 2 to the right hand side. That's equal to minus 2. Now I have 5x equals to minus 2, and to solve for x, I simply divide by 5, and x is equal to minus 2 over 5. Let's have a look at 3.2. It says, given p is equal to the square root of minus n plus 2x squared, the question wants us to determine x. That's very important in terms of p and n. What that simply means, it wants us to make x the subject of the formula. So we want to have x on one side of the equation alone. Right. So first things first, we want to get rid of this square root. And when we want to get rid of something in an equation, we apply the inverse. So what is the inverse of square root? We square, and if you square on the right hand side, we square on the left hand side. Then I'm left with p squared equals to the square and the square root cancelled over there, and I have this situation there. I still don't have x on its own, so I have to do more maneuvering. Let us get rid of this n first. So then I have p squared, the inverse of n is plus n. So I have it on the other side of the equation. And I currently have this. And then I want to get rid of the variable there of 2, the coefficient I mean. So I divide 2 here. And if I divide 2 on the right, I divide 2 on the left. That then gets rid of this 2 over here. I am then left with p squared plus n over 2 equals to x squared. Now we've discussed earlier over here that the inverse of square root is a square, and vice versa. The inverse of the square is a square root. So we want to get rid of this 2 here. So we're going to square root the right hand side. When we square root the right hand side, we have to square root the entire left hand side as it is. This will then cancel that 2 over there. You'll then be left with x equals to, and a huge square root over there with our fraction, p squared plus n all over 2. What is important to note here? When we square root, our answer always has a positive or a negative value. So it is plus minus square root of p squared plus n over 2. Very important to note this over here. Okay, let's have a look at 3.3. 3.3 says calculate the value of y if, and we have a big fraction over here, y cubed minus 64, and we have y squared plus 4y plus 16 equals to 3. Now we can see there's a cube there and there's a cube over there, and we can see the subtraction sign. So the first thing we're going to do is factorize over there. So let's start with that step. When we're factorizing cubes, difference of cubes, we know you're going to have a binomial and a trinomial. In the first binomial, we're going to have the cube root of the first term, which is y. We're going to have the sign minus and the cube root of 64, which is 4. Then the first term, yeah, we're going to have the square of the first term, which is y squared. And we're going to have all positive signs inside the bracket now. The middle term will be a combination of the binomial, which is 4y. And then the last term will be the square of the second term in the binomial, 4 times 4, which is 16. All of that will be over y squared plus 4y plus 16 equals to 3. Now, there's an interesting use of brackets we can apply in this case here. Because this is a trinomial, we can put brackets over there, okay? And we can say this is all a trinomial. This will help you to easily identify that these two trinomials are exactly identical. So we can actually cancel that entire trinomial over there, both of them. Then I'm left with y minus 4 equals to 3. Simply, now I take the 4 over. 3 plus 4, y is equal to 7 from there. Given minus 8 is less than or equal to minus 4x is less than 4. Now we need to solve for x if x is an element of integers. So x is basically an integer. Now we want to solve. We have minus 8 less than or equal to minus 4x minus 4. We want to have x alone in the middle, so we need to get rid of the negative 4. So we're going to divide by negative 4. What we have to do when we have the situation where there are 3 different sides, how can I put it? And I then divide by minus 4 for all of them. Okay, so what's important to note, when I then divide by a negative number, this signs will change. So I have minus 4 divided by, minus 8 divided by minus 4, which would give me 2. That now goes like this. I have x, that changes as well, and this becomes minus 1. Now we don't want to have a smaller number on that side. I can rewrite this as minus 1 smaller than x smaller or equal to 2. This is 2 is bigger than x. That means x is smaller. Or sorry, 2 is bigger or equal to x. That means x is smaller or equal to 2. That is why I can switch this entire thing around. I can just flip it over there. Because they've given us this indication x is element of integers, we can now state that x is not equal to -1. It's in between -1 and 2, but it's also equal to 2. So we can say our answers are 0, 1, and 2 over there. You can say that x is equal to that. 3.5 says solve for x and y simultaneously if x plus 3y equals to -5 and 6x plus 3y equals to 15. What I like to do, I don't like to use elimination. Okay, I like to use substitution. Right? I'm going to make x the subject of the formula for my first equation. Take the 3y over. I have -5 minus 3y. This is becoming my first equation. My second equation over there, right, is 6x plus 3y equals to 15. When I'm creating my first equation, I want to have either x or y equal to, or I want to make it the subject of the formula. This is important because I then want to substitute my x or my first equation into the x of the second equation. So I'm going to say substitute 1 into 2. So then I have 6, and when I substitute anything, I always substitute using brackets. 6 brackets minus 5 minus 3y brackets plus 3y equals to 15, right? Now I take the 6 and I multiply it inside. I have minus 30 minus 18y plus 3y equals to 15 over there. I'm just going to solve for y. So I'm going to take the minus 30 over, and I'll be left with these two terms over here. So I have minus 18y plus 3y. I am taking the minus 30 over because I want only the y terms to be on the left hand side alone. It's equal to 15 plus 30. That's 30, negative 30 that I took over. This becomes minus 15y equals to 45. For me to solve for y now, I want to divide by 15 on the left, sorry, negative 15, and divide by negative 15 on the right. This cancels. Then I'm left with y equals to 1, 2, 3, negative 3. I'm not done. I need to find x. Oh, sorry, I need to find y, and I need to find x. So I'm going to then substitute this into my first equation to find y. So then I have the equation 1, which is x equals to minus 5 minus 3y, and I'm going to substitute y is equal to minus 3 in there, and when I substitute using, that's correct, brackets. So minus 5 there, multiply, that becomes a positive 9, and x is equal to 4. So my two solutions, y equals to minus 3 and x equals 4. Right, let's have a look at question 4. Question 4 says, consider the linear number pattern here, 100, 97, 94. Determine an expression for the general term. Now this is quite simple. The general term is Tn equals to. Now what I like to do, what is the difference between the second term and the first term? I can see that to go from the first term to the second term, it is subtracting 3. So I put minus 3 in, right? That's always my difference. And then I ask myself, how do I go from minus 3 to the first term? So I'm at negative 3. How do I get to 100? I simply have to add 103. And then this is my general term. Okay, T26. 4.1.2, determine D26. So we know that n is equal to 26. This is telling us to determine the 26th term in the number pattern. So we can say D26 is equal to minus 3, 26 plus 103, and that is equal to 25. So the 26th term in the sequence over here is equal to 25. 4.1.3 says which term in the pattern is the first to have a negative value. Now this is going to take a little bit more understanding of mathematics. A negative value simply means smaller than 0. So which term in the pattern? So we're going to take the equation over there, right, and say if we find n, this term smaller than 0, which term in the pattern, right? So we're taking this general term smaller than 0, which is saying a negative value over there, and we're going to find n. Okay, that will tell us the term that is negative. Anyways, minus 3n, we take the 103 over, we have minus 103. Then we divide by negative 3 to find the answer. N is equal to 34.33. Now, it is not equal to 34.33. It is bigger than. Now, what happened over here? The sign changed simply because we divided by a negative number. So it went from smaller than to bigger than. This is telling us, of course, we cannot say n is 34.33. We are working with integers. So n, or whole numbers, or natural numbers, n is bigger than 34.33. So we can say n is actually equal to 35. So the 35th term will be the first negative value. Let's have a look at 4.2. We have a pattern here. Now we don't have numbers. We have variables as well. We have 3x minus 1, 4x, and 2x minus 5. They are the first three consecutive terms of a linear number pattern. Determine the value of x is the first question. Now, in order to solve this, there's something that we know. We know that the difference in a linear number pattern will always be equal. So we're going to use that. So the difference is equal to the second term minus the first term. And we can find that difference, right? We take the second term, which is 4x minus t1. We have to apply brackets there because it's more than one term. That gives us 4x minus 3x plus 1. That then is equal to x plus 1. That is difference, right? The difference also, we want to create two different equations to solve this. The difference also is the third term minus the second term. The third term is 2x minus 5 minus, and we apply brackets, which is 4x over there. Then we have 2x. I can put the minus 4x next to the 2x since they're like terms. Then I have minus, this is the difference, equal to minus 2x minus 5. Now, it's important to note that this difference is equal to this difference over here, right? It's the same difference, it's the same number pattern. Okay, so I'll just do it over here in blue so you don't get confused, running out of a bit of space there. So then I have minus 2x minus 5 is equal to x plus 1, and I can solve for that there. I'm going to take the x over, we have minus 3x equals to, I take the 5 over, it becomes 6. I then divide by negative 3, x is equal to negative 2. Now, 4.2.2, hence determine the sum of the first 5 consecutive terms of the pattern. So in order to do the sum of the first 5 terms, we need to find the first 5 terms because we don't have them. How do we find them? We simply have to now substitute the x value that we have into the sum. So we have 3 minus 2 minus 1, which is the first term, and the second term 4, and we substitute minus 2 into x's place, and we have 2, again minus 2 substituted in brackets, and minus 5. So This is minus 6 minus 1. So the first term is minus 7. This is minus 8 over there. And the third term minus 4. This is minus 9. Now what I can see here, I can see that it's minus 7, minus 8, minus 9. We need to do the first 5, so we are missing the and the fifth term in this pattern. Now, since I know it's a linear number pattern, I can then assume, not assume, I know that the next term is minus 10, and then the fifth term is minus 11. Now, remember the question wants us to do the sum. So, I have to add all these terms there, minus 7 plus minus 8 plus minus 9 plus minus 10 plus minus 11. You can save time. Try not to do this in your head in the exam. Quickly type that in the calculator. And minus 45. Okay. Let's have a look at question 5. Question 5 says your parents need 90,000 Rand to fund your tertiary education. How much money would they need to deposit into an account that now earns 9.5% per annum compound interest to ensure that they will receive the 90,000 that is required in 3 years' time? Now, the important information, we always jot that down. We need 90,000 Rand, which is at the end, and the deposit, we don't know. We need to find out what do we need to give, invest in, and the interest is 9.5% per annum compound. This is very, very critical because we have a compound interest formula and we have a simple interest formula. Now, the time is 3 years, and to find the amount, we're going to use this compound interest formula. We know A is the final amount. A is where we end off. So this 90,000 will be A, and the start will be P. So we don't know what we're going to start with. So let us plug it into our formula. We have 90,000, which is at the end, is equal to P that we do not know, brackets 1 plus, now interest is 9.5%. So we have 9.5 over 100. We always have a percentage over 100. Some of you can put 9.5 and then the percentage symbol in the calculator, but let's just do it like this over here. And then the exponent is 3 because the years is t, number of years. Then to find p is very simple. We're going to divide by this entire bracket. Very simple for us to do, right? And what we do on the left hand side, we do on the right hand side. You do it on both sides of the equation, and that's what we have over there, right? Then this will cancel, right? And then this will be p, and then putting that into your calculator gives you 68,548 Rand, 85. This is our final answer after plugging this into our calculator. And that's it. This is what we need to invest at the start to get at the end of 3 years 90,000 Rand. Okay, so question 5. Question 5 says Printco wants to buy a 3D printer priced at 4,200 Rand. They can purchase the printer on a hire purchase agreement. That's very, very important. The conditions of the hire purchase agreement is a cash deposit of 1,000 Rand, and the balance on the hire purchase agreement is 10.5% per annum, payable over 3 years in monthly installments. 5.2.1. What is the loan amount due on the hire purchase agreement? Now, first of all, I've dissected all the important information. The printer is 4,200 Rand. This is hire purchase. Deposit of 1,000 Rand. Interest 10.5%. Because this is hire purchase, we will need the simple interest formula, and the time is 3 years, payable over monthly installments. Now, the question wants us to calculate the loan amount due on the hire purchase. First of all, the printer costs 4,200 Rand. But for hire purchase, we always have a deposit at the start, most of the time. And the amount that I have to pay after deposit is what they're asking for. So I have 4,200 rand minus 1,000 rand. That's equal to 3,200 rand. This is the amount that I have to pay from the hire purchase, or that I'm going to actually loan. Okay, so I have to then pay back that amount, but obviously there's interest involved. So the next question asks us, calculate the monthly installment that Printco would need to pay towards the hire purchase agreement. Now, we've made an agreement, the hire purchase. We need to pay back a certain amount now. Okay, and we're going to use this formula over here to find out how much we need to pay back. So we have A, which is the amount we have to pay back. P is the amount actually that's been loaned to us, brackets 1 plus I is 10.5, but remember we're going to have it over 100, and we multiply that with 3. Okay, and we plug that into our calculator. 3,200, we have it over here, 3,200 brackets 1 plus brackets 10.5 over 100, multiply that by 3, close the brackets, and we get 4,208. That is the amount. 4,208. That is the amount we have to pay back now. But this is payable over 3 years, but we need to pay it over in monthly installments. We need to ask ourselves how many months are in 3 years, and we know 3 times 12 is 36. So we need to divide this 4,208 into 36 months. So we say 4,208, divide that by 36, and we get the monthly installments of 116.89. Let's have a look at question 5.3. The table below shows the exchange rates per unit for the British pound, US dollar, and Turkish lira in South African rand. We can see there that $1 equals to 17 rand 15 cents. In England, £1 equals to 23 rand 46, and in Turkey, 1 lira equals to 0.5 rand. The first question: Winston toured the United States and bought a cowboy hat for $35. How much was the cowboy hat worth in rands? Again, I've dissected the important information we need from that table and conversation question there. $35, we want to know how much will it cost in rand. Now, our conversion is $1 is equal to 17.15. So I ask myself, to go from $1 to rand, I see that I need to multiply to get to 70. I have to multiply this 1 to get to 17. Right? So I take the $35, very simple, $35, and I multiply by 17.15. That is simply it. So 35 times 17.15 is equal to rand. Yes, rand. Very important that we include our units for this question. 600.25 rand. The next question, 5.3.2. Anati decided to do the Cappadocia balloon flight. I hope that I pronounced that correct. In Turkey, and was charged 65 pounds for the flight. What did the excursion cost in Turkish lira? Leave your answer rounded to the nearest Turkish lira. That is also very important because you could lose marks for rounding off that last part in the question there. So we have in green the very important parts we need to go from £1 to rand, and then from rand to a lira. Since we don't have a direct conversion from pound straight to Turkish lira, we don't have that. So we need to go from a pound to rand, and then from rand to the lira, like this. So how much is 65 pounds in rands? Again, we're going from £1 to 23 rand. How do you go from 1 to 23? We multiply. So we're going to say 65 multiplied by 23.46. We put that in our calculator. 65 multiplied by 23.46. That is equal to 1524.9. Then this, remember, is in rands. We need to go from rands to the Turkish lira. So we're going this way now. How do I go? How do I get from 0.5 to 1? I divide by this exact number. That will give me 1. So for example, 0.50, and then divided by 0.5, that should give me 1. So to go from the rand to the lira, I have to divide by 0.5. I divide by 0.5, I get 3049.8. That's the Turkish lira. I don't know if the T goes in the front or not. Then I'll, in brackets, it said to round it off to the nearest Turkish lira. So we have to round it off there. So it's 30. We have to round up. So the 9 then affects the 4 as well. So it's then 5, 0. I don't know, Turkish lira in the front, in the back. Let us have a look at question 6. My goodness, if you stay this far in the video, you are quite committed. It's taking me, it's my third day to record this, simply because of time and energy and all of those things. But wow, to you are, hope you get level 7. Anyways, question 6 is, the graphs of f of x equals to b over x plus 1 and g of x equals to x plus c are sketched below on the same set of axes. A is the x-intercept of f and g. The graphs of f and g also intersect at b. B is 1 and 3. So we can see the graph over here. The graph of g is the green line, and hopefully no one's colorblind in the chat. And then f is purple. Okay, and the axis is blue, and then we have a asymptote horizontal for the f graph at 1. The first question says write down the domain or determine the domain of f. First of all, just a refresher on the domain is asking us, where does the graph of f exist horizontally? So what I can see from this side of the graph, it is goes all the way, this goes to infinity. So this will go to negative infinity over here, and then all the way to positive. No, it's turning and it doesn't want to touch 0. And if I look on this side, it then starts here, or it's going up there, but it doesn't touch 0, but then it goes all the way to positive infinity. So I can say then x is an element of all real numbers. You can also say x is going from negative infinity to positive infinity. However, x does not equal to 0. Okay, you could have also said x is bigger than 0 and x is smaller than 0 as well. But there's a few ways to write this actually, and you will get the marks from whichever way you do so. All right, the next question says determine the values of b and c. First of all, b is existing on the f of x graph, and c is existing with the g of x graph. Fortunately for us, we have this normally we call f of x, we call it y. We can do that. That's the y value that goes over there. Now we have 3 unknowns, but unfortunately for us, we do have a point which exists on both graphs. So we can then substitute the x and y values from this point to find b over there. So y is equal to 3 equals to b, we don't know. X is equal to 1 plus 1. That's just normal. So then b is equal to 3 minus 1, which is equal to 2. So b is equal to 2. Then to find c, also very simple. Y is equal to 3, x is equal to 1 plus c. I take the 1 over. 3 minus 1 is 2 is equal to c. I did it very fast. I know guys are sharp and you're also tired by now. So that is c and b. Now for the equation of axis of symmetry. Now we know what an axis of symmetry is. When we look at the f graph, what does it mean? It means where can I diagonally cut this graph so that I have 2 equal parts. So I can cut it going this way. I don't want to draw on this beautiful graph now, but you can cut it across going this way, and you'll see that it's even, and you can cut it across going this way, and it would cut the f graph evenly. So it's symmetrical. That's what it means. Normally the equation of axis of symmetry is from the origin, or it goes through the origin over there, but it has been shifted, and it's normally shifted, or assisted, it's normally shifted up, and you can look at the asymptote to do so. So you can see that the axis of symmetry equation has been shifted up by 1, right? So normally the equation would be y equals to x, but now it's been shifted up by 1, so it is plus 1. But there are two gradients, one going positively, one going negatively. So that means we're looking at the negative gradient, which would make this x over here negative. Now, 6.4 is asking us, for which values is f of x equal to g of x? Earlier we saw that our graph of f of x is equal to, since we found b, we said b was 2, so we can say it's 2 over x plus 1. We're going to need the equations of both the f of x graph and the g of x graph. And for the g of x graph, let me just get this quickly. It was, c was equal to 2, so we had g of x equal to x plus 2, if I'm not mistaken there. That is correct. Now, for which values is f of x equal to g of x? What is this asking? It's actually asking us, where do these two graphs intersect? And you can see they intersect at A and they intersect at B. Now, in order for us to find the values, we are simply going to equate the two graphs. So we're simply going to say, as this is saying f of x equals to g of x, so we're going to say the equation of f is 2x plus 1 equals to the equation of g, which is x plus 2. And we need to solve for x here. First and foremost, I'm going to take the 1 over, and have 2 over x. I can say minus x. I'm taking the x to the left-hand side. And I'm going to bring the 2 over. I can see in the future I'm going to have x squared somewhere along the line. So I'm going to bring everything to one side, because I can already see in the future a trinomial. That's from experience. So I take everything to the left hand side and I let it equal to 0. So then I'll have plus 1 minus 2 equals to 0. And so this is equal to minus 1 here. Then what I'm going to do, I'm going to multiply everything by x, because I'm not happy with this. So multiply by x, I have to do it to every term, even the, but it doesn't get affected on the right hand side. So I have this cancels. I have 2 minus x squared minus, this becomes x equals to, it stays a 0, because x times 0 is still 0. Then I rearrange the order, minus x squared minus x plus 2 equals to 0. And I don't want to have the x squared to be minus, so I'm going to divide everything by negative. So I change the signs, and all the signs change, and that sign change, but it's 0, so it doesn't really change. Now we have a trinomial. That's good for us. And we know how we're solving the trinomials. I normally make this x again. How you solve a trinomial, completely up to you. So I'm going to have a positive 2 and a plus 1. So I have brackets x plus 2, x, sorry, this is a minus 1. So I have x minus 1 there. And if I can just solve this here, it's actually x plus 2, x minus 1. It's actually equal to 0. Let's not forget that. And I solve this bracket first. X plus 2 equals to 0. Take the 2 over. X equals to minus 2. Or I look at the second bracket and I take the 1 over, or x equals to 1. So those are my two values. My first value, I could see the x is equal to 1. That's how I know I'm on the correct track. But this x over here would be, for the a, would be minus 2. Let's have a look at question 7. The graphs of h of x is equal to x squared minus 4, and the graph p of x, which is the red graph, is equal to minus x plus 2. They are sketched below on the same set of axes. A and B are the x-intercepts of h. C is the turning point of h. DF is perpendicular to the x-axis. That is very important information. Now, as we can see on the board over here, I have just labeled the important parts of the graph. The red graph being the straight line minus x plus 2. And we have the green graph, h of x equals to x squared minus 4. The first question says, write down the coordinates of C, the turning point of H. Now we know a normal graph starts at the origin, or the turning point is at the origin for the parabola. So the parabola being shifted down 4 units from this equation over here tells us that this point C, which is the turning point, can only be 0 and minus 4 because the y value has been shifted down 4 units. So since it's 1 mark, all we can do is say that that is the coordinates of C, which is 0 and minus 4. Next, 7.2. Determine the coordinates of A and B, which is the x-intercepts of H. Now, when we're doing x-intercept, we know we let y equals to 0. So from the equation, h of x, we know that h of x is y. So we say 0 equals to x squared minus 4. There's 2 ways to solve this. I'm just going to do it the quicker way. X squared equals to 4. I took the 4 over. And then I square root both sides. And I know when I square root an answer, a number, that the answers is both positive and negative. So x is equal to plus and minus 2. Now from this information, this is the x coordinate, and there's a reason why we have 2 possible answers is because there are 2 points in which the parabola intersect the x-axis. So we should know that b, which is on the positive side, that can only be the positive 2. So that's the coordinate of b, and for a, we know that since it's on the left side, it's a negative 2. So that is our answers over there, or our coordinates for a and b. Next, for 7.3, the point of f is negative 3 and 0. Determine the length of df. That's the next question there. So df is this length over here. Let me just highlight that. It's this length over here. Right. What's important is if we manage to find the vertical distance, and the vertical distance, since this is already at 0, whatever y coordinate is at d, that would be our vertical distance. So all I need to do is find the coordinates of the point d. Now one thing I already know is that f is minus 3 and 0, and f and d share the x coordinates as they are perpendicular there, this line. So we can plug either into the straight line or the parabola. Let us choose the simpler option. Y is equal to, we're taking the straight line, minus 3 plus 2, negative sign outside of a bracket, multiplies inside the bracket. This will give us a positive. So positive 3 plus 2, y is equal to 5. So the distance d of df is equal to 5. Let's have a look at 7.4. It says, hence or otherwise determine the length of db. Now, it's important when we look at db over here, we can see that there is a little bit of a triangle going on here between df, fb, and db. Now that's what I can spot over there. So there's only one way for me to get the length of this db. I can get, or not I can get, I already have the length of df, which was 5 units, right? And if b, this is very important to note, if was minus 3, right? So the x coordinate was minus 3 for if. This is very important because you want to find the length of fb. The b coordinate is 2. So from minus 3 to 2, there is a total distance of 5 units as well. So yes, so fb is also equal to 5 units, right? And we're going to put this over here. I don't want to mess up the triangle. So I currently have a triangle that is like this. There's a 90-degree, 5 units, 5 units. We need to find the hypotenuse, which is DB. Now we know how to use Pythagoras. That's a right angle triangle. We're going to say 5 squared plus 5 squared equals to DB squared. This is 25 and 25. That's going to give me 50 equals to DB squared. And DB equals to square root of 50. Okay. We can convert that to decimal, which is either 5 root 2 or 7.07 units. This is gonna maybe mess about my drawing. I hope you guys are gonna be able to see through this over here. Okay, I'm gonna use black. The question is now saying, what is the range of g if g of x is equal to minus h of x minus 3? Now, what's very important to note over here is that we want to substitute the equation of h of x in there to get the new equation of this graph. So I'm going to say minus h of x, which is x squared minus 4 minus 3. I can get a quick answer there and say minus x squared, that becomes minus and a positive, give me a positive. So positive 4 minus 3 is plus 1. So this simply means that it is a normal parabola graph, right? Let us start this normal parabola graph, except it is sad. So instead of happy, it's going to be sad. So I'm just going to mess up the drawing a little bit. So it's going to be there. However, it's been shifted up 1. So we'll just say that's 1 over there. So that g of x graph here that we're talking about, it's going to be around about there at 1. So we can see that the range is equal to 1 and smaller than 1. So y is smaller or equal to 1. That is the range that we have there for g of x. And we simply state that y is an element of all real numbers there. Let's have a look at question 8. It says sketch the graph y equals to a dot b to the power of x plus q if a is equal to minus 1, b is bigger than 1, and q is equal to 1. Now, there's important bits of information given to us here. Let us dissect each and every one of it. First of all, this equation tells us that the graph is an exponential function, so it should look something like this over there. Then, a equal to minus 1. A being minus 1 tells us that it's negative. It being negative tells us that the graph, exponential graph, will reflect across the x-axis. So it would look something like that over there, right? And then the effect of b will tell us whether it is reflecting across the y-axis. But it being bigger than 1, it will not reflect. It will stay as the original one would be in terms of the y reflection. So currently it is shifted like this over here, and then q being 1, meaning the graph will be shifted up by 1 unit. So currently the asymptote here is 0, so it being shifted up by 1. I can draw this quickly freehand. The asymptote is shifted up, and the asymptote is now at 1, and the graph itself will now go there and through the point of origin, and that would be 0, 0 over there. That is the asymptote and the shape. So those are the 3 marks you'll be getting there: asymptote, the shape, and 1 point. Just to cover why this point 0, 0 over here, we know that the graph normally cuts at 1 there. So it then reflecting here, it would cut at 1 there, and it being shifted up, now it would cut at origin over there. With a question like this, you could draw it quickly. You don't have to waste too much time to be accurate. As long as your lines are straight, your asymptote is straight. Don't try to do all of this freehand. The only one that's freehand is the graph, and you need to make sure that it has the correct shape. Okay, let's have a look at question 9. We're almost there. Wow, if you're still watching the video now, even kudos to you. And yeah, let's finish off strong. So for two events M and M, it is given that Pm or n is equal to 0.6 and P not M is equal to 0.7. Calculate P and if Pm and N is equal to 0.2. So we're going to do that one first for 9.1.1. By the way, this is like day 4 of recording this. So it's like a high production YouTube video that I'm posting, but it's just teaching. Anyways, so when it comes to these scenarios and all of that, we have a formula for that in grade 10 that we can use. And once I identify, this could be A or B, whatever two events, the letters doesn't matter. So in your official formula, shall we say, you'll have A or B here, and A and B and A and B. But we're working with M and N and two outcomes. So we can use that exact formula as it is, since we're only working with two outcomes in grade 10. So we have, the question wants us to calculate Pn, and we have a lot of information. Pm or N, we have that is 0.6. Pm, do we have? If P not M is 0.7, then Pm, so if P not M is 0.7, then Pm is 0.3. That is indirectly telling us the plus Pn, which is what we're looking for, and minus Pm and N, which is given to us as 0.2. Maths from here, people, maths from here. So 0.6, let's try and solve. Somebody drinking loud water. Let's try and solve this over here. So 0.3 minus 0.2 is equal to, okay, let me write it, 0.1 plus P in. I take the 0.1 over. That minuses 0.5 equals to P in. Then the next scenario is M and N are now mutually exclusive. What does that mean? The moment we say mutually exclusive, there is no longer M and N. They don't have a possible outcome where both of them can exist. In other words, so we can use this exact formula over here, except now, like we said, it's mutually exclusive, so this part of the formula falls away, right? And we need to calculate Pn now. It's the same thing. We're using the same information, but a different scenario. So Pm or N is equal to 0.6. We said Pm is equal to 0.3 plus P, and we take the 0.3 over. It subtracts from 0.6. I'm going quite fast. I know you're sharp by now, or you're tired. But yeah, 0.3 is equal to P of N is equal to Pn if they are mutually exclusive. Right, ladies and gentlemen, we are at the home stretch here. 9.2 is the last question. A survey was undertaken amongst 60 grade 10 learners as to what products they prefer when shopping online. The results of the survey were as follows. 37 learners purchased clothing, 28 learners purchased appliances, and 5 learners had never made any online purchases. X learners purchased both clothing and appliances. Very, very important. An incomplete Venn diagram is shown below. Redraw the Venn diagram given above in your answer book and complete the outcomes for each region in terms of X where necessary. So first and foremost, 37 learners purchased clothing. So I know this entire circle here is 37 learners. 28 learners purchased appliances. I can't put the number in yet because I have to subtract what they have together. So 5 learners had never made any online purchases. So I know that 5 is going to fall outside of the circle. X learners purchased both C and A. So if 37 learners purchased clothing, I know that here is 37 learners, but minus the X there, because that is part of the C circle. So clothing only is 37 minus X. The same applies to appliances, is 28 minus X over there. Since it's 28 appliances that are borderline, and I know that both is X, so I have to subtract whatever's in the center there. Okay, that is it for our 9.2.1. 9.2.2, we're gonna just finish off strong here. Show x is equal to 10. So what does this say? This says if I add everything, it should equal to 60. So 60 equals to, and I'm going to create an equation. Let's add 5 plus 37 minus x plus x plus 28 minus x. We have quite a long question over there. We're going to take all the numbers to the left hand side. So it's 60 equals to, no, 60 minus 5, can you see I'm very tight, minus 37 minus 28 equals to minus x plus x is 0. So I'm left with minus x on the right hand side. 60 minus 5 minus 37 minus 28. That answer there is minus 10 equals to minus x. I divide both sides by minus to solve for the answer, and x is equal to 10. So we can update our Venn diagram. So 37 minus 10 would be 27. We know that this over here is now 10. 28 minus 10 now is 18. So we have beautiful numbers inside there now without any variables. Then 9.2.3, we see that if a grade 10 learner is chosen at random, what is the probability that the learner only purchased appliances online? So that would be this 18 over there. So it's only uh, buying appliances online, 18 over 60. Okay, that is the probability there. You can simplify it. I think it simplifies to 3 over 10 over there. And the next question says purchased at least one of the two products online. So at least one. At least one. So that means it can either be this one or this one. It doesn't say it doesn't have to be both. It says at least one. So this is both. So if you buy both, you bought at least one. So it's 18 plus 10 plus 27 because you bought at least one of the appliances. So it's 27 plus 10 plus 18. And we should know why it's all over 60. That is the total amount of people. So 27, that's 37, that's 40, 50 to, I'm not mistaken, 20, 30, 40, 3, 5, 55, sorry, over 60. That's so stupid because 5 are not buying anything online. Yeah, very tired. Let us end the day. So purchase at least one of the products online, 55 over 60. Thank you for watching. All the best for the year and all the best for your exam, depending on when you're watching this video. Because I'm posting it in January. This is for my grade 10 learners that passed. So they're currently grade 11 and they need to just have a review. But you doing this maybe to prepare for grade 10, all the best to you. Thank you for watching.